Hi everyone, welcome to the first lesson for stage 5.1 statistics. We'll have a look at stem and leaf plots and a few other plots as well. The learning intention today is to construct back-to-back stem and leaf plots and histograms and describe data using skewed, symmetric and bimodal. This is the success criteria. These are the things I would like you to be able to do by the end of the lesson, so tick these. First of all, just a revision question. Construct a frequency histogram using this data. So you might like to pause the video, and when you're ready to check your work, press play. Should look like this. So down here we have height, here we have frequency. Vertically, you'll notice that we have 155 to 160, and that corresponds with a frequency of 3, which is in the table. So for 160 to 165, that's a 2. And we have 2 there. So all of these numbers should match up to the table. So that's a 9. This one's a 7, 10, 5, 5, and 1. And you'll notice that for 200, between 195 and 200, score of 0. So that's what a frequency histogram looks like. Sometimes you might see, instead of 155 to 160, you might see a number here giving an average or a median. So we'll add these two together and divide by 2. So let's look at a few features of this histogram. Histogram is a statistical graph for displaying frequency distribution of continuous data. Continuous data is things like heights, where we can actually measure more accurately. So our height could be 155, 155.3, 155.32. So just depending on the accuracy is the number that you write down. When we talk about discrete numbers, it's like the number of children in a classroom. So it's either going to be 23 or 24. You can't have decimals. But continuous data you could. And height is definitely one of those features. So it could be 155.5 centimeters. Histogram, graphical representation of information in a frequency table, as in the revision. Class frequencies are represented by the areas of the rectangles, centered on each class interval. So this is the interval between 155 and 160, and we're looking at the area here. So it's best if we have the same distance for each of these lines. It might be misleading if you have different widths of the rectangles, because we do consider the area. So for this histogram, we have a class interval of width 5 centimeters. So we're going from 155 to 160. The class frequency is proportional to the rectangle's height when the class intervals are of equal width. So this idea of the equal width is very important. Otherwise, the graph is going to be misleading, potentially. Next thing I want you to look at is back-to-back stem and leaf plots. So you can see here that we've got data for before and after. So we're looking at pulse rates for students, before and after gentle exercise. So the data before is this data, and the data after is here. So you'll see the scores for before are 68, so 6 and 8. When you put these two digits together, you get 68. Then there's another 68, another 68, and a 69. So just be mindful that the before scores operate that way. These number represents the number of tens, and then these units. So this number here is 104. So you write down the digits and make the number from there. 104. The before scores 86. So we start with 8 and then go to 6. 87, 88, 88. The next thing we need to think about is symmetry and skewedness. This one here is almost symmetrical. So if we draw a line down the middle here, this part, this shape here, could be flipped over to this part. So it's symmetrical. With the skews, if we have a tail on the negative side, we call it a negative skew. If we have a tail on the positive side, we call it a positive skew. So it's symmetrical if it is roughly evenly spread around some central point. And if it's not, it's skewed. So this was our central point here, central line, and it was roughly even on both sides. These two weren't even, so we call that skewedness. The definition here is for a positive skew, a tailing off for the upper end. So you see here, kind of has a little tail, and the big part is in here. So if it's at the upper end, the tail, we call that a positive skew. If the tail is at the lower end, we call it a negative skew. So we can have these three features for stem and leaf plots, histograms, and dot plots. So if we go back a slide, this one here we had lower end, lots of numbers there, and the tail at the higher end, so that would be a positive skew. And same for this one. The tail is at the upper end. We can also have bimodal data. Bi means two. Modal means mode. Mode is the most common score. So here we have a score of 1 and a score of 5 having the highest frequency. So there's two modes, so we call that bimodal. Time for some questions. So exercise 5.3 in your Maths Quest textbook are good questions. Page 192. I would like everybody to be able to do questions 1 to 4. Most of you should be able to do 9 and 11, and some of you can do 13 as well. Always reflect on the lessons. How are you going to remember these things? Start working on your summaries or posters for this new topic.